Okay. Welcome to the webinar, ODF webinar again. Great seeing you. Thank you for taking the time to join the webinar. I know it's just before WAPO, yeah, May 1st. But it's great that we can meet together this Friday afternoon together and learn about, in practice, how entrepreneurs, they are working with aquaculture and especially having sustainability in mind. And today we are going to have actually two speakers. We will have João, Rito, and Nicholas LaValle with us. And João is already here with us. And let me introduce João to our audience. He's a biologist, researcher, and he also collaborates with the Polytechnic of Leiria. And he has been a guest lecturer professor in courses such as bachelor courses in marine biology, biotechnology, or some master courses on aquaculture. He has also collaborated with the European Aquaculture Society and also the president of the European Aquaculture Society student group. He's also an executive board member of the Blue Alliance since May 2021. And João considers blue economy and especially aquaculture a very important instrument to help us solve part of the social, economic, and environmental problems of the world. So he now has become also an entrepreneur, and he's one of the founders and manager of the company SEAentia. So he will share with us about improving aquaculture sustainability standards through RAS operations. Yeah, thank you, João. Now the stage is yours.
Thank you so much. Thank you for this invitation. So I'm going to, I don't know, how much time do I have for the presentation? It's just a matter of me managing the time. 15 minutes, I guess, 15 minutes plus.
Yes.
Plus the rest for Nick that should be arriving. Oh, Nick is already here. Okay.
Yes, Nick is here
now. Okay, good. Okay, so I'm going to talk to you about aquaculture and how can we actually improve aquaculture sustainability standards. So we keep hearing from all over the world, so this is sustainable production and so on, but okay, it's tough to reach what we really call the sustainability. I think it's fair to say that we are increasing sustainability, but okay, not really there. So firstly, I'm going to show you some images about what some people think that is aquaculture. And these ones might be shocking, and they are supposed to be. So a lot of people, especially in Portugal, most people don't trust aquaculture sources. So because people just relate aquaculture fish to these kind of images. So they think they are poorly produced with poor practices, and they think that they're always full of diseases and so on and contaminants. But we can also imagine aquaculture in another way, which is by looking at these images, we immediately recognize the aquaculture industry. And these are cages in the middle of the ocean or the sea with very good technology, with fish being formed in the middle of the natural environment. And these are much more beautiful than the previous ones. This one, for example, is a new technology that has been developing, is a spur, and basically the cage can go underwater some meters to avoid the harsh conditions of the waves. And this one is the most recent, biggest project for aquaculture. It's called the Ocean Farm 1 from Norway. And it's basically a huge platform. It's based in oil platforms. And this one is what we can really call offshore cage, because it can really go offshore instead of being protected within the fjords. So, and deal with very big waves. But what I'm going to talk to you about today is not any of those examples that I've just showed you is something similar to this. So this is what we call aquaculture as well. And I'm sorry because there's a mistake on this. Let me just correct this. This is, again, this is what we call a recirculation aquaculture system, RAS. So this is another type of aquaculture, and we're talking about marine aquaculture using marine water, but all is done within doors. So in a completely controlled environment, land-based, hopefully and usually is located onshore, so close to the coast, where we can actually have access to the seawater. And why RAS? Why do we trust RAS technology? Well, RAS technology is, in our point of view, a way of assuring animal welfare. And to us, animal welfare is the most important point when we're talking about farming animals. Because not only, well, I'm going to talk about all the points. Well, first of all, obviously, because of the ethical matters. As a biologist, I do care about organisms, I do care about nature, I do care about animals, and would make no sense to me to farm animals and not taking care about them, not taking care about their welfare. So for obvious reasons, they are sentient animals, sentient organisms. Promoting suffering would not be the case, would not be the point on our operations. Also, because by taking care of the animal welfare, we have the outcome of having a better zootechnical performance from those organisms, because they are well treated. They can actually respond better they physiologically speaking, they do work better, they have better conditions. And those better conditions are reflected in the results and the performance that they have in these systems. One of them is the fast growth. So a fish can grow much faster if they are maintained in a good animal welfare. Obviously, a faster growth is very important for any entrepreneur, any farmer, because they will have the return on investment way faster as well. And they also can reach a better feed efficiency, and this is very important. This is one of those that I call one of the most important sustainability indicators. And why better feed efficiency? Well, better feed efficiency means, well, it's the FCR, the feed conversion ratio, and is as lower as better. Because, well, I can talk about some reference numbers. It's basically 10 for cows, 5 for pigs, and 3 for poultry, between 1 to 2 for fish in general. In RAS, we can reach levels of FCRs lower than 1, which means that we feed the animals with less than 1 kilo, and they grow 1 kilo of biomass. So they grow more than what they eat. This is really what we call an efficiency of converting the feed in the food that they eat into biomass. And why is this a sustainability indicator? Because we need to harvest some ingredients from the nature to feed the animals. And if we're harvesting less than what we are creating, then we are being much more efficient, and we are being more sustainable as well. The RAS is also a technology that allows us to guarantee that we don't have to use antibiotics or any other drugs, any other medicines to maintain the animal welfare, to avoid diseases or parasites, to assure the biosecurity of the animals. We can also increase the production by area. We have an higher production by area by increasing density. And this is a myth that is usually related with aquaculture, which is people do think that by increasing density, fish will be in worse conditions. Actually, it's not truth, but not also a lie, because by increasing the density, we are actually worsening the conditions of the water. Water quality is going to become worse. But if we have enough technology, or technology that is good enough to avoid the to avoid the water of becoming worse. So better saying, to maintain the water quality, then you can increase the density of the fish population. And by increasing the density, fish will also feel better as long as the water quality is maintained. And why will they feel better? Because they feel the protection by numbers. It's like they are in nature. So in nature, they gather together. You'll find them in schools instead of finding them alone. So they feel protected. And it's completely clear for a biologist, if you put few fish in the tank or a lot of fish in the tank, they do behave much better, much more naturally when there are a lot of them together. Also, with the RAS, we can reduce low water usage. We have low water usage. We reduce the water usage. Why? Because we recirculate the same water. So we maintain almost the same water from one day to another. So we only exchange about 5 to 10% of the water volume of the whole system, which is not what happens in other systems. And also, in this kind of facilities, we can also apply better slaughter techniques that are much more easily to be applied because we are land-based than what is able to what we can apply in the middle of the oceans, obviously. So also we bet a lot in circular economy to improve our environmental footprint. So we want to reduce our environmental footprint by applying circular economy techniques. And one of the things that we want to apply, and I'm not going to talk much about this because this is a topic for Nick, which is the nutrient recovery from the fish waste. So fish, obviously, they excrete some waste, but these wastes can be actually reused in what we call an SEAentia, Integrated Multi-Trophic Aquaculture systems. Also, in the end of the production, we can utilize the processing trimmings of the fish by channeling them to the fish oil and fish meal production, which is going to become another ingredient for another fish feed of other species. Well, these systems, I'm not going to lie to you, are very highly energetically demanding. However, becoming since we are located in land and in a building, in a flat building, is very easily by producing the energy through renewable sources. And now, just to finalize, I'm going to show you what we usually show as a pitch presentation of our company. So, based on all these concepts that I just talked about, we created SEAentia. SEAentia is a startup, an aquaculture startup located in Portugal. And we have the objective of tackle this problem, which is, are we able to sustainably feed the growing world population and achieve the excellence demanded by consumers in different topics like biosecurity, diversification, transparency, and sustainability? Well, according to the FAO, by 2030, fish production needs to be increased in 1.1 trillion, 110 million tons, which means that that we can reach 1.1 trillion euros of income. Our proposal is to produce what we call curvina. In English, it's called meager, but we prefer to use the Portuguese name, which is curvina. Which is a high quality white fish with a very good nutritious profile, an excellent taste, a low feed conversion ratio, fast growth, and it already has some public acceptance. And we will be the first company in the world producing curvina in a recirculating aquaculture system, and RAS, which allows us to promote the animal welfare and avoid diseases and parasites without using any antibiotics or other chemicals. So we will not contaminate the water and we will not contaminate your food. So this system is a system that we designed in an area to be implemented in an area of about 12,000 square meters. And that's going to be able, and I'm sorry, this is not updated, it's actually going to be able to produce about 1,500 tons of curvina per year. So the model is going to be with our own hatchery and farm. We can grow curvinas until 2.5 kilos. Then we can process the fish into different fish products like fillets, smoked fillets, slices, burgers, sausages, whatever. But all of them identified with our own brand, fully traceable and also certified. So, like I was saying before, we bet a lot in circular economy to reach our sustainability standards. And one of the things that we want to implement, not yet done, is to use the sludge as a fertilizer or for biogas production. To use the effluent nutrients to produce lower trophic level organisms, like I was just saying, through an integrated multi-trophic aquaculture system, and also to use the processing trimmings for fish oil and fish meal production. Regarding the solar energy production, we can cover the rooftop of the whole building. So we're talking about 12,000 square meters, and we can optimize the production of energy and we will have the payback of that investment in about 3 to 4 years, which is quite fast. So obviously we have our competitors, which are the fisheries supplying wild meager and the offshore farmers supplying farm meager, but we have a distinct advantage over them, which is to provide biosecurity, traceability, quality, and environmental protection all together in this piece that can be your food. And you, by choosing this food, you can help save the ocean. The team is comprised by me and Nuno Leito. We are two biologist friends who got passionate for aquaculture and decided to implement our knowledge to start a company and to play a bigger influence in the society. Also, other partners are the stakeholders, shareholders of the company, João Jones, Sonia Rito, Thierry Lousteau, and another company called All the Way. As a traction, I want to highlight the fact that we were the winners of the Blue Bio Value Program in 2018. So we are already a 5 years old company. We got the recognition. Well, we have several Horizon 2020 and Horizon Europe projects approved. So this is not again updated. This slide I shall update it. We're also a company recognized by the National Agency for Innovation as a company suitable for R&D. We were selected to the final of the Blue Invest by the European Commission, and we were awarded by the PwC with the Blue Revelation Diploma for Entrepreneurship in 2020. But more important than that, we have already a lot of companies and customers that are interested in our product. So any business will exist without customers, and this is something that we already attracted with our R&D project that we developed. So we are located in Peniche. I believe that some of you shall know where it is. So it's the biggest seafood hub in Portugal. And we've developed an R&D facilities over here in the port of Peniche. And we will be looking for scaling investment to replicate the farming units in several locations around the world where the market demands more fish. So the objective of the company is, well, we've developed everything, all the process in these pilot facilities. Now we're going to build the first farm, the first production and commercial farm. But the objective is to then replicate these farms in other locations and to make sure that we produce and commercialize it locally. So this is it. Thank you for your attention. I'll leave this, well, this is not easy for you to reach that, but we have a link in YouTube. You can Google it with our name, SEAentia. We have a small video that you can see for 3 minutes. Thank you. I will pass the word to Nick.
Thank you, João. Obrigado.
Sorry, can you, João, can you please put the link in the chat? That would be great.
Sure.
Thanks.
Sure, I'll do that. No
Yeah.
worries.
Thank you.
Thank you, João. And so probably the audience will have some questions, but let's wait after Nick's sharing. And let me briefly introduce Nick also to our audience. So Nick actually has 8-year experience with as environmental technician apprenticing at one of his father's small corporations. And he really keeps a very open mind regarding how the business can also have an impact on the world, on sustainability. And he has been the acting lead founder since Clean Valley's conception. And during the upcoming period, he has plotted a dynamic strategy for Clean Valley to enter the aquaculture market. And he's going to share with us on how the integrated multi-trophic aquaculture for onshore aquaculture. Thank you, Nick. Now the stage is yours.
I appreciate that introduction. Thank you very much. And hello to everyone. We are at Clean Valley looking to provide decoupled integrated multi-trophic aquaculture to the industry, essentially bringing back the ocean to land-based aquaculture. And of course, João's already given a perfect introduction to what aquaculture is, so I will be brief in my little explanation. I'll just provide some further stats on the industry as a whole and saying that it is growing. In fact, even as I speak now, this chart, which was famous for being shown around in 2015 to 2020, is now out of date, where you can see that aquaculture is near 50% to how we normally gather and get our fish to the dinner plate. In fact, now it's closer to about 75% of the fish that we are buying in grocery stores comes from aquaculture. And that trend is only going to continue to grow. So aquaculture not only is seen as the way we are going to feed the world, but as a more sustainable way we're going to feed the world. There's a ton of United Nations SDGs that have been tied to aquaculture, from not only providing cleaner water and recirculating economies, more innovative communities and cities, but of course, it will provide new ways to protect life below water and bring vitality back to regions in the oceans and our seas that have been left destitute for decades and hundreds of years. So aquaculture, as João showed you, is essentially fish in tanks, and it is a practice that has been around for, well, thousands of years, actually. When you think about pond aquaculture back in the ancient days of China and India, where you take fish, you put them in a pond, and you would feed them until they're big enough to harvest. But as we think of aquaculture in its modern sense, where you have large land-based facilities that are growing these fish, there is a few inherent challenges that every aquaculturist will face, and it's usually surrounding water and what to do with that end little bit of water that cannot either be treated or, well, reutilized. So the current alternative solutions are either dumping it into a local ecosystem or down into a municipal drain, having it trucked away to a facility, or treating it on site. And we are here to provide a solution to that, but we are not the only ones out there. So rest assured, do not get any anxiety, but there are plenty of folks out there that are looking to utilize that last little bit of waste of aquaculture that cannot be treated and try to grow different compounds from it. So there's a few companies in our competitor list that you can see here that are also looking to valorize the waste from aquaculture, turning it into algae. There's companies that are turning it into insect feed that can then be reused as a protein source. We are the only ones out there, though, that are going with probably, I would say, the most elegantly simple solution, and that is growing algae purely to then feed it to oysters. And that is where our area of expertise lies. So our way to provide integrated multi-trophic aquaculture to land-based facilities is we utilize that end waste that João was talking about that cannot be treated to grow microalgae from it. And we usually do that with what is called a polyculture, which is multiple strains of algae all working together. And that algae is a natural feed source for oysters. This is a completely natural thing. In fact, this entire concept is akin to biomimicry because we are mimicking what is being done in the ocean. When you look into the ocean, you don't see fish growing over here, algae growing over there, or oysters growing down here. They're all integrated into one harmonious ecosystem. And that is what we are trying to bring back to land-based aquaculture facilities. And when it all comes together, it looks something a little bit like this. You have your fish growing in a RAS facility, the end nutrients that are going to be going down the effluent pipe are then rather sent to our system where the algae is grown, the oysters are grown, and both are able to be utilized and valorized in different capacities. The big thing here, of course, is that for an IMTA certification for a facility is the increase of the price that the fish can then be sold on the market. This sustainable practice earns either marketing or accreditation in terms of how much the price of the fish can be increased. And what we've seen is that it can go upwards of about 5 times the original price. And of course, that is just for the RAS facility. We are also working with local oyster farmers in order to feed their oysters at the final stage before they're sold on the market. And in most places in the world, except for Canada and the United States for some reason, an oyster is not sold by the oyster, but it's sold by the pound. So if you are able to increase the weight of an oyster by feeding it a bunch of algae, you can then increase the price of that oyster and therefore also the quality. So that is the value proposition that an IMTA system can do in a commercial sense. And there's a bunch of other values that can also be brought forward with using an IMTA system like the one we have designed, from the fact that it is a decoupled system, so it does not provide any risk to the RAS facility, so that João and his team can focus on growing fish and doing what they do best, and we just worry about the algae and the oysters on our end of things. It, of course, increases the triple bottom line, where it's not only increasing the profit being made per year, but then also the value to the surrounding ecosystem and community. And one other thing I will, of course, mention is the fact that we are working towards having the ability to recirculate the end water that comes out of our biofiltration system. So right now, it is taking in that end effluent water and utilizing it for the nutrients that are within it. But we are taking step by step to be able to then clean that water so that it could be recirculated back to the facility and be reused as either a gray water or as a new source of water that can be used by the facility, which is a very important thing for parts of the world where there is not a lot of water availability ready for these facilities, or if there is high cost for utilizing water from a municipal site. Our model, we try and keep it as clean and simple as possible. Our system is bought, dropped off, and then integrated into the facility. We set up a maintenance agreement so that our technicians can operate our system without having to bother the folks or folks at SEAentia. And then we set up a subscription agreement with the oyster farmers to then take their oysters, grow them, and then give them back. And what it looks like when it all comes together is this 3D render here. So I do want to apologize for not having pictures of the active system at SEAentia, but this is the system here that we are going to be deploying at the end of May. And as you can see, there's a bunch of different applications that are available for it, from fish processing plants, oyster hatcheries, and of course, recirculating aquaculture systems. And this is within a 20-foot shipping container. It's completely containerized. It's a little black box that can be dropped off anywhere in the world as long as there is enough nutrients in the effluent water of the RAS facility, and of course, power. From our current tests, these are some preliminary results that we've seen over the last 5 months. So we were taking a keen interest in the amount of algae we could grow. And we were using a phytobacterium supplied by A4F. This algae was rather easy to work with, but it did have some cycles that made it interesting throughout the entire trial. And the biggest moment for us was near the end, around just before March, near the end of February, where we saw an exponential growth, and we saw nearly a spike of about 3 million cells per milliliter of algae being grown from the effluent from SEAentia. And then, of course, when we were feeding that to the oysters that we had in the next reactor chamber, we saw that the oysters were growing to about an average of 10 milligrams per oyster, which was really exciting. We were really happy with these results. And to give you a better idea of what is the system going to be deployed and how it all works and looks. So the Poseidon's biofilter is separated into 2 different sections. So as the effluent water is side streamed to our system, it runs through a raceway, which you can see on the right-hand side with that green-looking water. That's where the algae is being held. It goes back and forth through that. And then it is fed to what we call a jubaku system, which is crates stacked on top of each other where the oysters are being held, and they consume as much of the algae as they can during that time. This 3D render here and the previous one you have seen as I mentioned, will be deployed near the end of this month and will be running until the end of November for this year. And that is, right now, what you're looking at is a current timeline of this project. So we began back in March of 2022, got the schematics, the budget, everything approved by not only João and his team, but their engineering team, Landing Aquaculture. We assembled it in November and we began running it continuously until just last month when we put the system on stasis. And at this point, we are waiting for our manufacturer to finish building and send down the new system, and we will be proceeding onward from there. But we're really looking forward to it. We've kind of divided this whole project into 3 phases. So the first phase was looking at how can we purely take nutrient-rich water and grow algae from it and see how much algae we can grow. And perhaps maybe we can see a reduction in nitrogen and phosphates. There were no phosphates, so there wasn't anything to be concerned there. We didn't see too much of a drop in the nitrogen, but thankfully, SEAentia's biofiltration system within their facility was doing a bang-up job, so we didn't have to worry about that. So for phase 2, we wanted to focus on purely replicating that in the larger system that we're going to be deploying, the 3D render that I showed you. And that begins at the end of May, and then phase 3, after we've run the nutrient-rich water from the facility in that new system for a while and we're comfortable with it, we move on to phase 3, which is then the end effluent water and taking that purely rather than where we're currently grabbing the water from and trying to grow as much algae again from there, feed it to oysters. And there's 2 other side objectives that we have. One is there's a bit of CO2 exhaust that is currently being underutilized and being emitted. So we're going to try and funnel that into our algae because CO2 is actually a nutrient for algae and we can use it to grow even more algae. So that is the second goal. And then the last one is adding solar panels on top of our system as well to make it carbon neutral too. So the team that's been working on this and bringing it all together is, of course, myself. George Boyd has been the project lead and the chief engineer working on it. And he's been working closely with Hunter Bishop, who is our CTO, and reviewing and designing and putting it all together with a nice little bow on top. And then our contractor in the field, Corelli, has been, doing an incredible job, and she's quite fascinated by the ebbs and flows of the algae, and it's been wonderful working together as a team. Behind us, of course, is an incredible group of advisors, mentors, and folks with far more experience than us that have been helping us get to this point, and an incredible network of collaborators and other expertise matters that are able to bring in either the manufacturing or the legal documents or all that other fun stuff that makes this all come together. So we just want to say thank you to the folks at Clean Conduit and Arm Aqua, Landing Aquaculture, of course, and I'd be remiss not to say thanks to A4F and folks at the Blue Bio Alliance and João and his team at SEAentia for being such incredible hosts, for allowing us to do this at their site. And that is all for me. Thank you very much for your time and for your patience. If there are any questions, of course, for either myself or João, feel free to bring them forward or put them in the chat. Happy to answer them.
All right. Wow. Big hand for both of you.
Great work.
Yeah. Mm-hmm. I love the collaboration. I think that's so exciting to see. And it's so important too. I mean, we have to come at these challenges from different angles. Sorry, that's my coffee heating up. But I thought it was interesting, Nick, you were talking about the CO2 capture. That was also an interesting,